Okay, hopefully you have written down or in some way have recorded what the matrix elements were that we had from the previous part. So now I'm going to show you using a TI-83 how we can do the math to find the currents. So the first thing I need to do is to locate where the math is, or the matrix math is. And to do that, on the TI-83 plus here, it's second function and then that inverse function. Now that brings up three menus. So going side to side, I can go through different menus. And what I want to do to start out with is to edit the matrix, because I need to make the matrix. So I'm going to make matrix A, and I need to put in the number first of rows and then the columns. So because I had 5 variables, I have 5 rows. And because I'm going to slam on to the end the answers, I'm going to have 6 columns. The first 5 will be the 5 columns in my matrix that I labeled A, and then the 6th column will be the column vector that I labeled B. So I'm going to make a 5 by 6, and now just put in the numbers. So if you have your matrix, you can just follow along. Minus 3. Notice you have to put the negative that's down at the bottom, not the minus sign. Enter. 0. Enter. 0. Enter. Minus 2, enter, 0, enter. So that's the first row. Now I'm getting to the answer. So the first row for the column matrix or column vector B was minus 6. Go down to the second one, it was 0, 0, minus 6, 0, 0, minus 10. Next one, 0, 0, 0, 2, minus 12, 0. And then 1, 1, minus 1, 0, 0, 0. And my final equation, minus 1, 0, 0. You know, I don't think I wrote that equation right. It should have had... Oh yeah, I'm thinking of matrix, or the node 3. So now I've entered entries for all of them, so I need to leave the matrix. So to leave the matrix, second quit. Now, if you're curious if you entered it right, you can always go back to second matrix, and then for names, I just have A highlighted already. Click enter. There's saying matrix A. Hit enter and it'll show me matrix A. So you can see the values in the matrix and make sure that they match what they're supposed to be. So first column 3, 0, 0, 1, minus 1. Second column 0, 0, 0, 1, 0. Third column 0, minus 6, 0, minus 1, 0. Fourth column minus 2, 0, 2, 0, 1. Well, final column of the A matrix 0, 0, minus 12. Screwed over there, minus 12, 0, 1. And then the answer part, minus 6, minus 10, 0, 0, 0. So since that's correct, now I can do my math on it. So back to matrix, and now I want to do matrix math. Now the function is RREF, which is down near the bottom here. I'm actually going to go up because it's less key clicks to get there by maybe 1. So there's RREF. So now I have a function RREF. I need to use matrix 1, so second matrix, choose A. There we go. Hit enter. Boom, there's my answers. Notice I have the unit matrix, 5 by 5 unit matrix, and then I have each of my currents. Now you have to be a little careful. Make sure you come over and make sure there's no scientific notation there that's going to make the answers different than you think. And so here we have all the answers. Notice they're all positive. That means I actually guessed correctly on the directions of all of the currents. Didn't necessarily. I was actually hoping that the bottom 2 might be wrong, but I was just guessing, and turns out I randomly guessed right. So there's how we can solve this set of equations very simply using linear algebra. Now, I don't expect you to be a pro at linear algebra. You may not understand everything I said about the linear algebra, but hopefully you understand how we're converting the simultaneous equations, 5 simultaneous equations in this case, into a matrix, and then we're putting the answer part to make it a square matrix, in this case a 5 by 5, and then with a column vector at the end to make it a 5 by 6, and then the RREF gives me my answers. So that's how you do the linear algebra.